Welcome, students. This is instructor Sandra Hindo. We are officially on Lean Six Sigma White Belt, lecture number 4. If you're following along in the Lean Six Sigma White Belt slide deck, please turn to slide number 67. We are first going to be taking a look at the Six Sigma roadmap and methodology. Six Sigma has two primary roadmaps: DMAIC and DMADV. DMAIC is when there is an existing product or service that has a quality issue and it needs improvement. So you define the quality problem, you measure, you analyze, you improve, and control. Whereas DMADV is when you are in the process of designing a service or a product and want to make sure that it's going to meet customers' expectations. CTQ stands for critical to quality. It's all the variables that your customers require of you in terms of the product or service that you are offering. So remember, DMAIC is when you have an existing product or service, and DMADV is when you are designing a brand new quality, brand new service or product. So there's two methodologies, and both of them involve fundamental statistical concepts, as well as methods and tools, which we'll be learning about in the following slides. Think of it as the funnel from broader to narrow topics. As you know, critical to qualities are critical to quality characteristics, also known as variables. They are characteristics of a product or service that are important to customers, are measurable, and have defined specifications. Critical to quality variables are the focus of our efforts in Six Sigma. CTQs must be identified, developed, and managed and improved. They should be reviewed and in some cases revised or retired. This is a life cycle that provides a framework for application of Six Sigma methodology. Let's look at this very carefully. First, we have design and launch. This is to design to deliver critical to quality variables. You predict, optimize, and you verify performance. And then you support, improve, and feedback. You monitor indicators to improve poor, critical to quality variables, and you learn from the past. After that, you discover the need. You identify new opportunities, external or internal, product, process, or services, and you establish the measures, identifying critical to quality variables for offerings. My students often ask me, well, what do I do first? Well, it depends. If it's a brand new product or service, obviously you're going to first discover the need and you're going to establish the measures. And then you're going to design and launch, and then you're going to do support, improve, and feedback. But then it's a continuous cycle. There's no beginning or end. So you might start out this way, but once you get support, improve, and feedback, you learn things. And as you gather new feedback, whether it's from focus groups, whether it's from surveys, whether it's from the customer service center, you take that feedback and you go back to discover the need, establish the measures. You improve on that product or service. It truly is never ending. So looking at the yellow itself, determining what variables are critical to quality for your customers, which is what CTQ stands for. You design and launch, you support, improve, and have feedback, and you discover the need, establish the measures. CTQ Lifecycle provides the framework for understanding the application of Six Sigma methodology. And sometimes it's not even designing and launching a brand new product or service. It could be an existing product or service, and you're looking to improve it. Let's look at the 2 Six Sigma methodologies. First, there is define, measure, analyze, improve, and control. This is the methodology used in Lean Six Sigma, known as DMAIC. You must first define the opportunity, then measure the symptoms, analyze causes, improve solutions, and sustain the positive changes that you made. DMAIC provides structure and rigor to problem solving. The second methodology is known as DMADV. This is when you are designing a brand new product or service. In this one, you define, then you measure, analyze, design, and verify. So you define the program description. 2, measure needs and requirements of your customers. 3, analyze high-level design. 4, design detailed design. 5, verify. You do rollout and control. We'll look at these phases in some detail in a moment. However, at this point, focus on the middle bar. The general thought process is simple. Define, it has everything to do with what is the charter for this team? Why is this issue important? What process is affected and who will be on the team? With respect to measure, you must ask the question, what performance is expected? And if there is a baseline, what performance is currently exhibited? What does this tell us about the process? In the measure phase, you must gather baseline data. And then you get to the analyze phase, which is number 3. In the analyze phase, you ask the questions, what are the primary drivers of this performance? Number 4, improve or design. You ask the question, what actions can and will be taken to drive performance to a new level? Lastly, there's control/verify. What are the basic control mechanisms to assure that the new performance will be sustained? So in the middle now, you see that there is the project charter, then performance, then the drivers, actions, and then the controls to sustain those positive changes that are made. So in conclusion, DMAIC provides structure and rigor to problem solving. DMADV drives customer needs into product and service design. We're going to be looking at both of these in great detail. Simple, powerful methodologies. All these processes are gauged by their performances that is expected and or set by the process owner or organization. Be it from sales prospecting to training to software, each process is tracked for its performance over a period of time at set intervals. You can look at a multitude of processes and performance, right? Name something you're working on and look at these. These include sales prospecting, contract negotiation, order entry, supplier qualification, manufacturing assembly, service fulfillment, accounts receivable, professional hiring, acquisition due diligence, travel readiness, training schedules, software transition. Or name something you are working on or planning to work on when you get to the Black Belt or Master Black Belt course. Before we implement the process, it must be well planned. We need to plan for several key elements, including planning/design. So when it comes to the product and service, what are the key to quality? What is critical to quality? These are the variables that your customers demand from you. What are the volumes required? Now, when it comes to the people, what are the employee skill requirements? What's the number of staffing required? What are the training requirements of your employees? When it comes to the process, you need to map out steps of the process and the methodologies to improve the process. When it comes to equipment, what are the capabilities of equipment and the utilization of equipment to make the process as good as it can be. In terms of the facilities, what's the size and the layout to get the job done? Lastly, you have measurement, and you include both metrics and policies. So when it comes to performance, the down arrow indicates better, and as you go up, it's worse. And then you look at the passage of time. We begin operation here. In this scale, higher is worse, more scrap, longer cycle times, and so on. So we want to get to better. We will plot performance over time here. We hope that it does decrease over time and that performance improves. As we begin operations, we also begin tracking performance. We can see that the process does vary a bit from point to point. So on the left-hand side, you have performance. As it goes up, it's worse. As it goes down, it's better. And you get to see how the performance and process operates over time. So if you start all the way to your left, it's pretty good, and then it goes down to better, but then it goes up a little bit, then it goes down, then it goes up, down, up. Ooh, there's some ups and downs here. I don't see that we're sustaining the process that good. Do you? Process and performance. So it gets worse, then it gets better, then it gets worse, and then it gets better, and then it goes a little bit up, and then it goes down. And then it goes up, and then goes down, then it goes up, and then it goes really down. Yeah, this is not a sustainable process. Maybe employees are falling off the track a little bit. Maybe there wasn't enough training or not consistent training, but this does not look good. In this case, even though there is variation, we can also see some stability. The averages do not seem to change, and the limits of the variation also seem to be about the same from time period to time period. So in this one, yes, they're within the customer spec limits because all of the data points are within the customer's upper specification limits. Those are the dotted lines, and within the lower customer specification limits. Well, when I look at this, I would like to, in an ideal situation, in a very, very tight process where training is consistent, I would like to see, I don't like seeing that peak. You know, the peak between the first segment and the second segment, I don't like seeing the peak, how it kind of goes up. That means, to me, it's not as tight of a process as it could be. It is clear that if nothing disturbs this process, no special causes of variation, that we could predict the process would perform within these limits in the next time period. And the truth is, as long as it meets the customer's upper and lower specification limits and all the data dots are within the upper and lower line, then you're good to go. You can really call this process both stable and in control. However, as we know, sometimes things happen. And now they're including data points that are way too high, and they're totally above and beyond the upper control limit, and that's in that circle thing that you see. These are called special causes. What happened to cause these special occurrences? Process behavior has changed. It looks like there's a specific problem. Something has changed, and we should be able to identify what it is. Whatever change can likely be found in the records right here. I don't know how I feel about this one. I want it to go back down. When we identify the cause, we take action. If an operator was not trained, we might provide training, or we might replace the operator with an experienced one. If a system has failed, we might institute a preventative maintenance program. So obviously, some preventative maintenance program took place, or we replaced the operator, or we trained the existing one, because all of a sudden, after that special cause, we see the data points going back to normal, which is a good thing. We have not changed the design of the process, just found a specific deviation from the design process and returned it to the state it had been in. Performance now returns to its previous level, so we're all good to go. The process now appears to be back in its previous stable state. We could again predict, barring another special cause, performance into the future. The process may be in control state, stable, predictable, but it's still producing waste, whether in the form of scrap, wasted cycle times, or lost customers. So let's take a look at these again. What's causing the issues? We look at the product and service. We look at the critical to quality variables. We look at the volumes, the people. Do they have the skills required? The number of staffing. Is there training that's taking place successfully? We look at the process steps. Do some steps need to be removed, added, tweaked? We look at the methodology. With respect to equipment, is it capable? Is there the utilization of the proper equipment? When it comes to the facilities, we look at the size and layout. And then lastly, for management, we look at metrics and policies. And there's still waste. The whole reason, just to go back to the beginning, the whole reason you're sitting in this class, Lean Six Sigma white belt, is to get rid of the waste in the process, right? When you get rid of waste, your product or service, the quality increases, and you cut costs. We need to identify what in the design of the process is driving the level of performance and or the degree of variability. That is the role of DMAIC, is to identify the root cause of the performance/behavior exhibited by the process and to identify the appropriate solution and method of sustaining the change. How to reduce waste. Ideally, in the world of Lean Six Sigma, you want to only produce 3.4 defects out of 1 million opportunities. And that's only achieved by removing the waste, the error, and the mistakes. We need to identify what in the design of the process is driving the level of performance, the degree of variability, or both. The role of DMAIC is to identify the root cause of performance exhibited by the process and to identify the appropriate solution and method of sustaining that solution. True improvement is performance at a level we had not previously attained, whether that is the level of variation or the average level of performance. To make such an improvement, we first need to define the problem, measure the symptoms, behavior of the why of the problem we've defined, analyze the potential causes, elements of the process design based on the symptoms uncovered in measure, improve the design based on the results of the analysis, and finally, control. Control/sustain the process at the new level of performance. Ideally, you're going to have side-by-side process maps. The first process map is going to look at your baseline process. And then you're going to implement, train people on the new improvement plan. And then you're going to have an ideal state process map. And we hope that the changes in the process leads to the results that we're looking at, whether we're measuring a decrease in process cycle times, a reduction of errors, defects, mistakes, deviations, what have you. So we've seen this one, the product, services, people, processes, equipment, facilities, and management. That's the planning. Then you need to control, sustain your improvement plan. DMAIC is the process of determining what process factors should be changed, what they should be changed to, and how the new process should be sustained. Let's look at the DMAIC overview. DMAIC is the structured methodology for problem solving, process of investigation, and is rigorous in nature. DMAIC must not become periodic. I can't say that word anymore. Let me attempt it one more time. Bureaucratic. Yay, got it. Or paperwork intensive, rigid or inflexible, mechanical / check the box. So, DMAIC questions. Here it goes. In the define phase, we ask, what is the problem or opportunity? Why should this be a priority? What is the effect of the problem? What processes are affected? Who should be on the team? For the measure phase, we ask, what is the primary critical to quality variable and how is it measured? How good is the measurement system? How bad is the problem? Are there any clues about the problem's behavior? In the analyze phase, what could cause the symptoms? How much impact will we have? What return will there be? How much impact will we have? What return will there be? In the improve phase, we ask, what are the root causes? How were these causes verified? What could be done about each cause? What will be done? In the control phase, we ask, how will the solution be implemented? Who will be effective? How will the change be sustained? What are the verified impacts? See, each phase of the project is aligned to the others. The answers to questions in one phase lead you into the next. The inquiry and tools in a subsequent phase will depend on the answers in the previous one. This is a more organic way of looking at DMAIC, a process of discovery. So let's take a moment. Let's see if I can use my little laser. I don't know if it's really a laser or not. Okay, it looks pretty nice. I'll use it. So remember, in defining, you are going to choose only one dependent variable. What's another word for dependent variable? It's the quality issue that you are focusing on for your Lean Six Sigma project. What is the problem? Give it one variable name and stick with that name throughout your Lean Six Sigma report. In the measure phase, what's the most important thing you're going to do? Is collect the baseline data. I want to see how bad the situation is right now. Tell me the number of defects, the number of errors, the number of variability. We need baseline data. When it comes to the analysis, the most important thing is that you determine the critical X factors, also known as the vital few X variables. Which variables are impacting your dependent variable the most? In other words, what independent variables are causing the most impact to your quality problem? And in the improve phase, you create the improvement plan and you train people on the improvement, which includes following the tweaked process map or the more than tweaked process map. Could have been lots and lots of change, right? Not just a little tweak state. And lastly, you want to control, sustain those positive changes that were implemented during the improvement plan. And ideally, when you do your Lean Six Sigma report, you want to be able to state that there is a statistical significant difference in the reduction of errors or mistakes or variability before and after the implementation of your improvement plan. Think of DMAIC as a series of questions grouped into logical phases. DMAIC phase deliverables. For the define, you're going to have an approved charter, which we're going to look at soon, the project critical to quality variables, and a high-level process map. Well, I'll show you how to create one very soon. And then for the measure, you're going to identify the project response variable, which is your Y, also known as your dependent variable. Only have one per project. So you're going to collect your one dependent variable, which is the Y. You're going to assess the performance standards. You're going to analyze measurement system capability, determine performance capability, and establish improvement goal or goals. Analyze. Prioritize list of all X's. Identify the likely families of variability, the vital few X's. Perform graphical analysis, perform ANOVA, use of basic statistical tools, quantified financial opportunity. Now for the improve phase, you're going to confirm the vital X's because that's what your improvement plan is going to be based on. You're going to have an optimized solution, confirmed solution, and the Six Sigma risk assessment plan. Lastly, you're going to control those positive changes that you made. There's going to be a sustained process. You're going to mistake proof the process. So you're going to prevent the mistakes from occurring in the first place. You're going to provide tolerance limits to the process. You're going to monitor statistical process control, the performance. You're going to have project documentation, translated learning, rewards, recognition, celebrate. Six Sigma is not about the tools. Why are tools such an important part of the curriculum? The answer is that the answer to that is that use of the tools helps to develop the sense of critical thinking and scientific perspective necessary for successful problem solving. Statistics, more than simply a branch of mathematics, is a way of viewing an environment. It is a collection of tools, it is a methodology, it is a thought process that dissects the large picture into smaller parts and resembles it into a more efficient configuration. Let's look at this very carefully. Let's first see the characterize the problem, and then we're going to optimize the solution. So the first three stages, define, measure, and analyze, is where you characterize the problem. So for define, what is the opportunity? Measure, what is the problem? What are the symptoms? For analyze, what are the potential causes of the problem? And then when you optimize the solution, you do that in improve and control. For improve, what are the root causes and the remedies? That's where you create your improvement plan. And then control, how do we hold the gain so people don't go back to the old way of doing things, right? So for the critical to qualities and the whys are defined in the define phase, you're going to have the charter, project charter. You're going to create the scope. You're going to create both your X and Y variables. You're going to have a process description, and you're going to create your problem statement. Now for the measure phase, you are going to have the dependent variables baseline data. Y and measurement analysis, you're going to collect your baseline data. You're going to have valid specifications. What are your customer specifications, both their upper and lower specification limits, and you're going to have the symptoms analysis. Now for the analyze phase, you're going to list all potential X's, list of likely X's, the XY relationship, which in other words, if you guys remember your research methodology classes, is the impact of the independent variables on your dependent variables. You're going to have your hypothesis, your preliminary contribution analysis, and the financial estimates. When it comes to improve, you're going to have confirmed root causes, proposed solutions, financial benefits, and the risk implementation plan. Lastly, you have control. This is where you have the process design, your tolerances, your controls, your final Z, and the final benefits. More on that in future slides. Lastly, you want to do market research. You can do like affinity diagram, quality function deployment, especially when you're designing a product or a service, and you'll have SIPOC mapping, which we'll be learning about. This is just a little brief overview. So the metrics and operational definition, you got your gauge reliability and reliability, descriptive statistics, graphical analyses, process mapping, process capability. This is all that we're going to be learning about in greater details when you move up into the belts. This is just telling you what some of the tools that are available. And then for the analyze, you have the cause and effect diagram, stratification, ANOVA, T, F, and chi-square statistical analysis, which you learn about in the black belt courses. When it comes to the improve, you have your standard operating procedures, your design of experiments, regression, risk analysis, Pew matrix, action planning. Lastly, for control, you have design, tolerancing, error proofing, monitoring, and SPC. The great thing is when you work your way up with the belts, you're going to be learning in great detail about each of these DMAIC tools available to you, but here's just a very broad elementary understanding of the processes and tools available to you. How do you select which project you're going to focus on? So when it comes to choosing Six Sigma project, first you can look at raw project ideas. The origins of projects may come from many sources. Many customers may be having similar problems as reflected in complaints, feedbacks. Satisfaction surveys may reveal an issue that should be addressed. Defect errors or cost analysis might highlight problems. So when it comes to the project definition, the project ideas then should be described briefly as a preliminary scope. Priorities should be established for the projects on this list. Next, you identify the key inputs, process steps, outputs critical to quality variables, and the stakeholders. A project team may be required, and these should be identified. When the individual or team is ready to execute the project, a project milestone chart should be developed. The appropriate stakeholders and approvers should agree to the project. This process, beginning with the generation of ideas and ending with the approval, creates a funnel of projects and should be continually managed as a source of improvements. After, design for Six Sigma projects might be established with the same process. In these cases, they will be focused on redesigning products, services, or processes that require extensive redevelopment. However, most DFSS product development projects will be created based on the requirements of the Worldwide Product Plan and NPI, New Product Introduction Processes. So let's look at this diagram very carefully and hopefully inspires you a project that you want to work on when you get to the Black Belt and Master Black Belt courses. So how do you know what's a worthy quality problem that you want to investigate for your project? Well, you can look at defect prevention reports. You can look at software quality assurance reports or customer complaints / feedback. Or what about employee complaints and feedback? What's making them tired at the workplace, right? Business / department needs / market demand. Project manager meetings. These are really all great ideas where you can stem your Lean Six Sigma project from. And these are all pool of project ideas. This is preliminary project scoping, prioritized list of projects, scoped projects. You have the charter, team, milestones. You have project approvals. And then the green belt and black belt project execution. This is the Six Sigma project funnel. We are now moving on to define phase deliverables. You have your project critical to quality variables. You have your approved project chart, which we're going to look at in detail in further slides. We're going to look at how to create a high-level process map. Fully trained team is formed, supported, and committed to work on improvement project. Customers are identified and high-impact characteristics are defined. Project charter is developed and business process is mapped. Team readiness. Team is sponsored by a champion or business leader. Team is formed and team leaders are assigned, such as master black belts, coaches, black belts, and project leads. Improvement team members are fully trained on Six Sigma and DMAIC. And then you have to create your project charter and business process mapping, which we will be learning about in further slides. The project charter is completed and signed off by key stakeholders. Business process map is completed, verified, and validated high level as is, not how it should be or could be, right? Just what the true current state looks like. SIPOC representation is completed, describing the suppliers, input, processes, outputs, and customers. And we're going to be seeing all these. We're going to be seeing what a project charter looks like, what a business process map looks like, and what SIPOC looks like. And once we see the examples, you'll know exactly how to create one yourself. Let's look at a project charter. If you're anywhere close to being a project manager or have been involved in projects, you've probably seen a project charter many times. A project charter is a one-page concise description of your Six Sigma project definition. Studies have shown that one of the most important factors for successful Six Sigma project completion is a properly defined project. Completing the charter ensures that critical project definition steps such as defining the scope of the project, identifying critical resources, and so on are considered. Your champions and functional manager stakeholders' approval help ensure proper project support. The project should be considered a working document as you progress through the defined phase. After its completion, the signature section is used to confirm buy-in by all critical stakeholders. The completed charter ensures proper project selection prior to entering the project in the Six Sigma database. Now I'll take a moment of silence so you can look this over. And then when you're in your PDF, you get to see this much big picture, but you get to put the title of your project, the date, who's working on it. And one of the most important things here as you analyze it on your own in future PDFs is as followed. You have to create a problem statement. You need to describe the critical to quality variables and the impact. You need to include the project scope. You need to include your goal statement. You need to describe other potential benefits to the organization or the customer. And when you're in the PDF, I want you to examine this very, very carefully because you can use the same exact template or a very similar one when you start completing your Lean Six Sigma project. You can make it as fancy or simple. This one's a little fancy, but you can make it as simple as you want it to be. So let's look at this problem statement. To optimize, reduce the caseload and tool for patient cases. And then some other good things as well, but I'll let you look slowly on your own for these because they might just be easier with your slide deck that you receive. So when it comes to the defined phase tools, there's a stakeholder analysis, market research, SIPOC, quality functional deployment, and you engage in a stakeholder analysis. You want to know who your stakeholders are, who's strongly against the project, who's neutral, who's strongly supportive. You want to know how you're going to have to work each one to come in agreement with you and what is their role. And if they don't agree, how do you overcome that obstacle? Do you need to overcome that person? Who are the stakeholders? Where do they need to be? What's their role? Do they have a typical role, a required role, a typical and required role? Because the last thing you want is to not identify who your stakeholders are, and while you're going through the project, realizing that you're not going to be able to get anything done. So, identify the typical roles of the stakeholders based on their perceived levels of commitment. Identify the required role which you think they should be for project success. Display their needed path, commitment, level change through arrows. Take a moment to examine this. And then for I, it's the input required. A, are they accountable? M, are they a must? R, are they required to review any of the project charters or do any sign-offs? So identify the expected roles from the stakeholders phase-wise. Make sure you correctly identify those accountable. And the Greenbelt team is a must hence. And the Greenbelt team is must has M in this row. So a must. This is a wonderful place for us to stop. We've officially covered 29 slides in lecture number 4. When we come back to the next video, we shall continue on defining what the SIPOC is and really dig deep into its components. Until then, some people are asking for a break. Feel free to go take a break, 15-20 minutes. And when we all come back, for lecture number 5, we shall begin with a PowerPoint slide, SIPOC definition. Thank you, and I can't wait to see you guys soon. Bye-bye.